When I say trusted computing, what do I mean? And I can't blame you for not being entirely sure because, let's be perfectly honest here, it's used as a buzzword. So let's start with trusted computing. What do we mean by trust? Well, the trusted computing group, and we'll talk a lot more about them this afternoon, or possibly later this morning, completely. They say that a trusted component is one that is predictable. Now, it is important to note that by this definition, trusted and good are very much not the same thing. I can have a machine that is full of viruses, and as long as I know it is full of viruses, it's trusted. Don't look too hard at that. But the core idea here is we really care about predictability, because once we've got reliable predictions, we can build a system that is a more layman's term of trust by deciding which of these predictable systems are actually ones we want to interact with. So there's two general reasons we may want to decide to trust a system, or that we can predict a system. The first, and the one that we strongly prefer, is that we have reliable evidence, preferably verifiable evidence, that that system does in fact meet certain criteria. The second is that we don't have a choice, or we have some out-of-band assumptions where I'll let them play with the Zoom, where we assume that this hardware, for example, is good, like the TPM, because we can't verify it. And realistically, all trusted systems end up coming down to this. Even if you manage to find a TPM manufacturer who will let you go and inspect the factory and analyze the chips, fundamentally at some point you have to trust something blindly, whether it is your auditor who is verifying it, whether it's the manufacturer who says, if IBM says this chip is good, very few people have the expertise to actually check and make sure that that's correct. So fundamentally, at some point, all trust comes down to we assume for some reason, because we think IBM wouldn't be in business if they undermined their chips or whatever, we assume that it is trustworthy because we have to. That said, most of what this class is going to be about is taking these out-of-band assumptions and turning them into reliable evidence about everything else. This is what TPMs are really for. So when we talk about reliable evidence, the way we get that is a process called attestation. And when we talk about these out-of-band assumptions, the component or components that we are blindly trusting are what we call the root of trust. Why? Because it's the thing at the bottom of our chain of trust that we're going to be building, in which we trust higher level components. So trusted computing is unfortunately not exactly a precise term. In general usage, we mean systems that use hardware, usually the TPM, to provide some kind of security support for software. So today, when we talk about that hardware, it's almost always the TPMs, but there are also some special processor modes in your CPU that, Intel's is called TXT, AMD has one that's called SVM that does the same thing. And no, I don't actually know what SVM stands for. TXT is Trusted Execution Technology. But in the future, we are probably going to be seeing more variations. There's a specification being worked on right now for mobile trusted modules, which is basically a slimmed down TPM-like thing that lives in your cell phone. So that when I start saying, well, I'm going to pay for things with my cell phone, I have a little more cryptographic assurance that that's a safe thing to do. But we also use trusted computing to refer to infrastructure that relies on systems that use hardware to support the security of their software. So sometimes this is something as simple as a software application where we're perhaps doing system measurement. Often this is large scale, things like network access control. There are also things like secure storage devices, which kind of blur the lines here. So there's a lot of things that go into this umbrella term of trusted computing. But in general, when we're talking about trusted computing, we're talking about systems that either use or provide resources for building trust in a large system for some purpose. And yes, that is big. So, yeah, I wasn't sure how much detail I should go into there. Zeno is pointing out that, so in the Intel world, there is TXT, the Trusted Execution Technology, which is sort of the security side of things, and something called VT or VTX, which is the virtualization technology that is used to build a lot of our modern fancy virtual machines. Really cool stuff. The AMD SVM actually does stand for Secure Virtual Machines and does combine that virtualization and that trusted side of things, and they just use one umbrella term for both, which is a little confusing when I'm trying to remember what SVM stands for in the trusted side of the world rather than the virtualization side of things. Thank you, Zeno. So in terms of the vision of trusted computing, this is what people dream about, just to be clear. This is not what we've got today. This is where we're driving forward in the future. First, before logging onto a computer, I'd like to know that it's good before I hand it my password. No, that's hard. All of these are hard. A machine that isn't up to date, that doesn't have its current patches, might be routed to a DMZ that only contains patch machines so that it has to perform its update before it can connect to the broader network. DMZ is demilitarized zone, term for a quasi-trusted network. Servers can find out which machines they're actually talking to and whether they're providing good, whether they're running good data before, or running good software before providing data. So we can imagine this in, we've got all of these privacy concerning areas. You've got HIPAA in the medical world, and you've got financial regulations. Wouldn't it be nice if I knew before handing over financial data or patient identification data that the machine I'm handing it to is not going to publish them on the internet, and that I actually know exactly where things are going to. We can establish audit trails. There are a lot of applications for which this kind of identification and confirmation of my communications partners is very powerful. And we'd also like to make sure that all of my data, including my keys, can't be stolen by somebody who's got a Trojan on my machine with a remote network connection, and they can't come in and just hoover up my data and take it all apart at their leisure. We're not at all of these places yet, but we're moving in that direction. So, very high level, this is sort of where the technologies we've been talking about fit into the workstation view. You've got an operating system that's got a bunch of applications, and underneath it all, pretty much below where the applications largely pay attention, you've got a TPM, and you've got a CPU that has certain trusted extensions in it. And there are much more complicated workstations that we can build. We can do beautiful things with virtualization. We don't care about that right now. This is just a sense of where these hardware technologies fit into the workstation. And of course, once we've got workstations that are built on a foundation of a TPM and TXT and so forth, we can start getting into higher level broad things like network access control, where they actually use those trusted workstations as endpoints, for example. So you might say that if you've got a bunch of client machines, they have to use their TPM to prove their identity and provide integrity reports, and we'll get to what those integrity reports are and how we can provide them to some gateway that actually evaluates them before letting them on the network. Now, this is a structure we use today all over the place. The problem is today, our best guess for, so, are you any good, is the machine says so, which is not really the best gauge. And of course, there are lots of applications beyond that, some of which I'll talk about today, but this is sort of from the small to the large here. So I mentioned earlier the Trusted Computing Group, because I used their definition of trust. The TCG is an industry consortium, although it does have some government partners and some research partners. that defines the standards for trusted computing. They're in fact people who, I believe, established the term trusted computing, and if not, they're close enough to not make much of a difference. And as a group, they have a very layered vision. They want to establish a whole bunch of technologies, starting at the hardware level, and then move up to protocols and communications protocols and certificate formats, and then all the way up to applications. So they have lots of work going on with a lot of different levels. There are work groups that focus on specific subsets of this massive problem. Most of the work groups that I actually interact with are the technological ones. There's a TPM working group that establishes the standards for the new TPM. There's a mobile solutions group that's establishing that mobile trusted module and so forth. There are groups that focus on interoperability. How do machines using component A talk to machines using component B, or two different machines using component A? Given that we've got two TPMs, both of which are dumb little hardware chips that talk to their software, what does that look like when I'm trying to use them across a network or across an enterprise network where I want to coordinate 5,000 machines? Those groups, infrastructure group has one, the Trusted Network Connect working group is huge. And there's just started spinning up some working groups that are focused on use cases. How do we use trusted computing in a server environment? How do we use it in a multi-tenant architecture, aka a cloud? So there's a lot going on in the TCG. We are not going to cover the vast majority of this in this class, in part because a lot of it is under NDAs, and in part because it is ridiculously complicated and you don't really care about most of it unless you're actually interested in that specific subgroup. But just so you know, there's a lot going on here. If you want to know what's currently going on in trusted computing, if you want to get a picture of the world as the TCG sees it, they've got a website, and you can go take a look there. All of their specifications do eventually get publicly released, although licenses and some of them are a little funny. And just so you know, if you come across on the internet mention of the Trusted Computing Platform Alliance, that's what the TCG called themselves back in the early days of the 2000s. So, you had a question? This is not a comprehensive list. There is a virtualization working group, and I do a lot of work with them, so if you want to talk about that, I will happily talk about that at more length than you care about later on. So, why do I mention the TCG? Sometimes we have to trust people because we don't really have any alternatives, and the TCG is fundamentally the group that we end up trusting because we have no alternatives. Their standards are actually, many of them being adopted, and these are what define the components we can easily get that we have to trust. So we can evaluate these standards to determine if we should trust them, because we don't always want to trust all of them, and we don't always want to trust all of them for every purpose, but they're out there, we can evaluate them, and people are implementing them. The TCG also does have compliance programs. And when the TCG talks about compliance, this is not the level of government usually talks about compliance, but it is noticeably better than nothing. There are minimum standards that people are supposed to meet. There are compliance tests, and you can talk to them about what their test suites look for. So these do give us a foundation that we can build trusted systems on, and we can actually look at them as researchers and as users to decide, given that this thing on the box says it has a TPM, we can go back to the TCG and say, what does that mean? How do we use it? And start evaluating these technologies. Unfortunately, the TCG is not actually very good at communicating with users, to say the least. It has one of the worst websites I've ever seen for actually providing information in a reasonable and coherent fashion. And the last time I went on there just to look for how do I use trusted computing, I got a list of companies that were using trusted computing, which was not quite what I was looking for. So there's some room to grow, but there is a lot out there that is actually very useful. Sorry about that. That better? Yep, cool. So, Any questions about this before we proceed on into the fire hose that is the TPM? Where we assume that this hardware, for example, is good, like the TPM, because we can't verify it. And realistically, all trusted systems end up coming down to this. Even if you manage to find a TPM manufacturer who will let you go and inspect the factory and analyze the chips, fundamentally at some point you have to trust them. There's two general reasons we may want to decide to trust a system or that we can predict a system. The first, and the one that we strongly prefer, is that we have reliable evidence, preferably verifiable evidence, that that system does in fact meet certain criteria. The second is that we don't have a choice, or we have some out-of-band assumptions where I'll let them play with the Zoom. When I say trusted computing, what do I mean? And I can't blame you for not being entirely sure because, let's be perfectly honest here, it's used as a buzzword. So let's start with trusted computing. What do we mean by trust? Well, the trusted computing group, and we'll talk a lot more about them this afternoon, or possibly later this morning, completely. They say that a trusted component is something blindly, whether it is your auditor who is verifying it, whether it's a manufacturer who says, if IBM says this chip is good, very few people have the expertise to actually check and make sure that that's correct. So fundamentally, at some point, all trust comes down to, we assume for some reason, because we think IBM wouldn't be in business if they undermined their chips or whatever. We assume that it is trustworthy because we have to. One that is predictable. Now, it is important to note that by this definition, trusted and good are very much not the same thing. I can have a machine that is full of viruses, and as long as I know it is full of viruses, it's trusted. Don't look too hard at that. But the core idea here is we really care about predictability, because once we've got reliable predictions, we can build a system that is a more layman's term of trust by deciding which of these predictable systems are actually ones we want to interact with. So